This section deals with interest as applied to a savings account. Let me show you two formulas that we're going to do here, and one is called compound interest and the other is called simple interest. We'll start with simple interest. And that we don't put the interest, there's not a formula for the interest. There's a formula for the total amount that you have in the account. And it looks like this. APR is the annual percentage rate. P is called the principal. That's how much you deposit initially. A is the amount. Let's call it the account value. And Y is the number of years. So a quick example looks like this. Let's put $100, so deposit $100 into a savings account. That pays 5% simple interest. And so now let's keep track of how much we have year over year. So after 1 year, we have, so the P, the principal in this case, is 100. That's the $100 that I put in. The APR is 5%. You'll want to change that to 0.05. And then Y is the number of years. Since we're doing it for just 1 year here, I do this. And it turns out this will be $105. Now what about after 2 years? Well, it's the same formula. So I have A equals 100 times 1 plus 0.05 times 2. And here I think you'll find that we have $110 after 2 years. And the same formula works for over and over again. After 10 years, what do we have? So we still have the same P as before, same APR. This time the number of years is 10. And it looks like I'll have $150 then. So this is simple interest. It's the most basic type of interest that you can possibly compute, but it's never used. Simple interest is never used in any business whatsoever. However, it is used to develop compound interest. So that's about as far as I'm going to go with simple interest. The rest of this will deal mostly with compound interest. Here, the formula looks similar at the beginning. But then we get an interesting thing inside here. I get APR divided by N, and then I have N times Y up there in the exponent. So the A and P have the same things as before. The A is the account value. The P is once again the principal. That's the amount that you put in. APR is the annual percentage rate. And then we have n. This is the number of compoundings per year. I'll explain what those are in just a minute. And then did I have anything else? Yes, I have y, which is the number of years. So we're going to do the same thing that I did in the first example, except I'm going to look at different schemes for compounding. So let's start with deposit $100 into an account that pays 5% compounded annually. All right, so the formula now is going to look something like this. We're going to have A equals P times 1 plus, now the APR is 0.05. You want it as a decimal. The N is the number of compoundings per year. If I say I compound annually, that means it's only one time a year. So a 1 goes down there. And then up in the exponent, I have 1 times however many years I'll have for Y. So let's track what it has year over year over year. So after 1 year, we have A equals 100 times 1 plus 0.05 divided by 1 to the 1 times 1. And I think you'll find that just like simple interest, this will give us $105 as before. What will change, though, is when we go to multiple years. So after 2 years, the formula looks like this. Now this one I don't happen to know off the top of my head, so I'll grab the calculator for this. All right, let's see if I can do it on this calculator. 100, I'm going to start a parenthesis, 1 plus 0.05. I don't have to divide by 1, but I'm just going to do it to see how hard this is. Okay, so I've got the parentheses down. Now in the exponent, I need to put a 2. 2. So I have $110.25. Notice if we go back to the simple interest, after 2 years it was only $110, so this made a little more money after 2 years, 25 cents in fact. After 10 years, let's take a look. We have A equals 100 times 1 plus 0.05 over 1 raised to the 1 times 10. So I have 100, start me a parenthesis, 1 plus 0.05 divided by 1, end the parenthesis, and now I got to raise that to the 10th power. We have 100, I'm going to round to 2 decimal places, so it looks like 162.89. And if you look at the simple interest version of this, after 10 years it got to $150. Okay, so how does this interest work, this compound interest? Well, the way it works is if you leave your money in the bank, it will accrue interest. And at the end of a year, they will take all the money that you have and the interest you've accrued, and that will all of a sudden be the amount that is in your account. So whatever money you've made in the year plus the original amount together will earn interest in subsequent years. Simple interest doesn't pay interest on the interest, it only pays interest on the principal. That's why we're just getting like $5 each year from simple interest. But this will build as you compound more and more each year. And that's exactly what I'm going to do next. So remember, this was compounding annually. That's why it had that 1 under there. That means at the end of the year, you take your money and the money that you've earned, and together that's the new account value. That's what will draw interest for the next year. That means interest is computed once a year and that's it. You can do compounding more often than once a year. Here we're going to do it again. We're going to deposit $100 into an account that pays 5% APR compounded quarterly. So now the formula is going to look like this. See, that 4 will be underneath of there now. And then I'll have 4 times y in the exponent. So let's follow this around as we go from 1, 2, and 10 years. So after 1 year, here's what we have. The 100, start my parenthesis, 1 plus 0.05 divided by 4, end my parenthesis. Now the exponent is just to the 4th power. And here I have 105.09. After 2 years, we have A equals 100 times 1 plus 0.05 over 4 to the 4 times 2. 100, start my parenthesis, 1 plus 0.05 divided by 4, finish the parenthesis, and take it to the 8th power. Here I have 110.45. Now, if you look back at our previous one, we only did it 1 time a year. We have, after 1 year, we had 105 like the simple interest. After 2 years, we had 110.25. And in this system, we have 110.45. So not only does more time give you more money, but the more often that you compound, the more money you'll have as well. This basically means that compounding 4 times a year means that every 3 months, the account value is recalculated, and that new amount is what interest is figured on. Let's do after 10 years. We have A equals 100 times 1 plus 0.05 over 4 to the 4 times 10. 100, start my parenthesis, 1 plus 0.05 divided by 4, and finish the parenthesis. And now I'll raise it. If you're going to keep 4 times 10 instead of 4D, make sure you put parentheses around your exponent, otherwise it won't work out correctly. Here I'm just going to use 40. It's easier just to multiply it in my head. Here I got 164.36. And you can see that is better by a little bit than the previous version. There are two other compounding schemes that are most popular, and that's monthly and daily. So let me just redo this example with both monthly and daily. So we're going to deposit $100 into an account that pays 5% APR compounded monthly. So now the formula is going to look like this. We're still going to have the $100 we're putting in. Still going to have my 0.05, but now it will be over 12. And then I'll have 12 times y will be in my exponent. After 1 year, we'll have 100 times 1 plus 0.05 over 12 raised to the 12 times 1. 100, start my parenthesis, 1 plus 0.05 divided by 12, end of the parenthesis, and then take that to the 12th power. I get 105.12. You notice that's slightly more than we had for even the annual, quarterly compounding was 9 cents, and this compounding gave us 12 cents. After 2 years, we have 100, 1 plus 0.05 divided by 12, finish the parenthesis, and then raise it to the 24th power. I got 110.49. And then after 10 years, like the other ones. Here we'll have A is 100 times 1 plus 0.05 over 12 to the 12 times 10. 100, start my parenthesis, 1 plus 0.05 divided by 12, finish my parenthesis, and then raise that to the 120th power, and enter. Let's see what we have. 164.70. So how did that compare to our, a little bit more than our quarterly compounding. Looks like we got 34 more cents out of the deal. And then for my last example, we'll do the same thing, but we'll do daily compounding. So we're going to deposit $100 into an account that pays 5% APR compounded daily. So now the formula looks like this. Now let's go ahead and plug in our numbers. So after 1 year, I'm pretty certain that most interest is done daily. So your bank accounts and all that are updated every day, for example. So after 1 year, we have A equals 100 times 1 plus 0.05 divided by 365 to the 365 times 1. 100, start my parenthesis 1 plus 0.05 divided by 365, finish the parenthesis, and raise that to the 365th power. So I get 105.13. I think this is 1 cent more than we got on the last try. After 2 years, we have A equals 100 times 1 plus 0.05 over 365 to the 365 times 2. That exponent happens to be 730. So 100, start my parenthesis, 1 plus 0.05 divided by 365, finish the parenthesis, and now take that to the 730th power. And I get 110.52. How'd this compare to the last time? 3 more cents. And then after 10 years, $100, start a parenthesis, 1 plus 0.05 divided by 365, finish the parenthesis, and then we're going to raise that to the 3,650th power. 164.87 is what I ended up with. So if you go back to our previous one, we had 164.70. Here we got 17 cents. Now keep going back here. Remember 164.36? 162.89. This one here was annual compounding. And then come back to here. Simple compounding had the lowest amount. So we went from 150 all the way to 164 something. 164.87. Another concept in this class, or at least in this section, is called the annual percentage yield. And what this is if you have compounded interest, this tracks what interest you would need to have in a simple fashion in order to equal the compound interest. In other words, this is what I mean. We want the amount, here I want P times 1 plus 0, I don't mean to put anything in there, let me come back here. APR over N times Y, all right, what I'm going to do, this is what we want to happen. I'm going to divide out the P's, okay? And then N is the number of times that you compound per year. So suppose I made a mistake in here. And what we could do is we could do after 1 year. So if I do y equals 1, for example, here's what my formulas look like. Now this is really easy to do. Let's consider N equals 4. Let's try quarterly compounding. APR equals 5%. So we have 1 plus 0.05 divided by 4 raised to the 4th power, and that equals 1 plus APY times y. So I can see where I can get the APY from. If I simplify over here, 1 plus APY equals this stuff. And then I can subtract 1. And now this is something we can do on the calculator, and this will give us the interest rate as a decimal. I'll start my parenthesis, 1 plus 0.05 divided by 4, end the parenthesis, and I'll take that to the 4th power. And I'm going to do 4 decimal places. So I get 1.0509. And minus 1. And that will just give us the APY then. But they're going to want it as a percentage. So change this to 5.09%. So in the formula that I have for this is that the APY equals 1 plus APR over n to the n minus 1. And is, of course, the number of times that you compound. So as an example, compute the APY for APR equals 6% and N equals 12, so monthly compounding. So according to my formula then, APY, that will be 1 plus 0.06 divided by 12. That'll be raised to the 12th power, and then we'll subtract 1 from start my parenthesis. 1 plus 0.06 divided by 12, finish my parenthesis, and then take that to the 12th power, enter there, and then subtract 1. And I get 0.0617, or as a percent, 6.17%. Whenever you're given a problem like this, it's not a bad idea to catalog all the things that you're given at the beginning. Like that's the principal right there. There's my y. The APR is pretty evident. So our formula is going to look like this. Remember, it looks P times 1 plus APR over N to the N times Y. Our principal there is the 12,000. Our APR is 4% or 0.04. We're doing this quarterly, so I'll put a 4 down there and a 4 up here. And 8 years, so I'll put 8 for the Y. So I have 12,000 times, so I'll start my parenthesis, 1 plus 0.04 divided by 4, finish my parenthesis, and then I'm going to raise that to the 32nd power. I get $16,499.29. So there's a straightforward use of the formula. We've got the formula for this. Remember, it's APY equals 1 plus APR divided by N raised to the N minus 1. So in our case, We have compounded daily. That means n equals 365. There's our APR right there. And I don't think I need anything else, so let's plug those in. 1 plus 0.0525 divided by daily, so that's 365, raised to the 365 minus 1. So let me start my parenthesis. 1 plus 0.0525 divided by 365. Finish that parenthesis. And now raise that to the 365th power. And see what I got? And then I'm going to minus 1 from that. So it looks like I have 0.0539. 0.0539. Or 5.39%. Notice that the APY is always a little bit higher than the APR. The APR was 5.2%. But if you're going to accomplish the same financial goals but using only simple interest, you have to use a higher interest rate. Here's a fairly reasonable question to ask. Let's say you want to deposit money into an account so that it grows to a specific amount that you can one day withdraw and have more money. So how do we do it for let's take a look here. We got $55,000 is how much we want. We want to do it in 6 years. So I'm going to put $55,000 into the account. So let me put the formula back up here for a second. And let's see what we have. We have this right here is A. That's how much we want to have at the end of the 6 years. 6 years, so there's our Y right there. Is our 6. Down payment on house, assume no additional deposits are made. Annual compounding, that's N equals 1. And then there's the APR. So let's put all those numbers in. So P will be the thing I'm looking for. 1 plus, where's my APR? 0.06 over 1. And I'm going to raise that to the 1 times 6. Now I'm probably just going to do this to 4 decimal places. So I'm just going to do this parenthesis part. So I'll start my parenthesis. 1 plus 0.06 divided by 1. Finish that parenthesis. And then raise that to the 6th power. I have 1.4185. I think 4 decimal places will be plenty. And now if I want to get P by itself, I'll divide by 1.4185. And I can finish this off with the calculator. Let's see, 38,773.35. So there's how much we would need to have initially deposited in order for it to grow to that much. This problem here stops up a lot of students because it doesn't tell you how much money is initially invested in order for it to triple. But we do know we put in an amount of P. So what we need to solve is this. So how long will it take is we want the original amount that we put in to triple. So I'm going to divide by P. Now, I'll put in the numbers that we know. Compounded annually means that N equals 1. And the triple, I've got that 3 on the left-hand side, and there's my APR right there. So let me rewrite this. 3 equals 1 plus 0. Actually, since the N is equal to 1, 0.0539 1.084, and that will be raised to the 1 times y power. In fact, I'm going to do a real simplifying here and do that. So basically, y is going to be the number of years that when I do this computation, if I equal 3, that's the number of years. Now remember, y has to be a whole number. So this problem requires trial and error. In order to solve this in a higher level math class, we could use something called logarithms. We don't have those available in this class, so we have to use trial and error. That means I'm going to plug in different values for y until I get to or exceed 3. You'll see what I mean. Let me pull up the calculator. Let me move it out of my way so we can see what's going on here. All right, we're going to do 1.084, and I'm going to raise it to the 10th power, just a guess. Notice that it's 2.24. It's not quite big enough. That means raising it to the 10th power wasn't enough. So I'm going to try to the 20th power. So I'm going to do 1.084, and I'm going to raise it to the 20th power. Notice it's over 5 now. So when I raised it to the 10th power, it was too low. When I raised it to the 20th power, it's too big. So naturally, the thing you might want to try to do is raise it to, say, the 15th power. Let me back up here. So I'm going to go back up there. 1.084. Well, naturally, I'll go in the middle and try 15. So here I'm a little over 3. When I raise to the 15th power, I get 3.35. Let me try to the 14th because I'm really close now. So I'll start my parenthesis. 1. I don't know why I keep starting the parentheses. I don't need to. 1.084. I'm going to try to the 14th power. I'm still over 3. So next I'm going to try to the 13th power, 1.084, and I raised it to the 13th power, and it's under 3. So it happens in year 14. And since it's annual interest, that means it happens after 14 years has elapsed. So let me put these numbers in. When I did 1.084 to the 13th, I got approximately 2.85. But then when I did 1.084 to the 14th, let's see what that one was approximately. That was 3.09. So that means that the y equals 14.